Okay, we are live. So, hey everyone, welcome to Practically We Bring Learning Alive. So, I hope I'm audible and the screen is clearly visible, right? So, if I'm audible enough and the screen is visible, could you all please type yes in the comments so that we could begin our today's session? And also, let us wait for students to join. And you all are aware, right? CBSE has released their schedule of class 10 term 2 exams, which starts the end of April, correct? So I hope your preparation is going well. I hope you are giving enough hours for each subject and be well prepared for the exam. So in the term 2 one short series, today we will be going through the chapter surface areas and volumes. Okay. So yes, so as you're aware, like surface areas and volumes, first term topic is deleted, correct? So we will be seeing the surface area and volume of the other 3D figures, the other solids, and we will also solve problems on it, okay? So before that, let us go to the schedule first. So today is 12th Feb and we are dealing with the topic of surface area and areas and volumes. So on 14th February, you have the topic on our environment. Next is statistics on 15th Feb. 16th Feb, it's magnetic effects of electric current, right? So next, we are thinking to shift this sample paper, like the schedule of the sample paper, and we'll be informing you as soon as possible. Next is coding. Coding for class 10 time slot is from 8 to 9:30 p.m. and these are the courses, these are the topics you'll be learning in computer science or coding classes, and the dates are as follows, correct? So now that we are done with discussing the schedule, and I hope you have taken a screenshot so that you could follow the classes without missing any one, right? So today, what are we dealing with? We are dealing with the topic surface area and volume. And we will see the introduction of the topic. We will see the formulae of 3D figures or solid figures. We will see surface area of combination of solids, volume of combination of solids, and also conversion of one solid shape to another, right? So let us begin with, so what is surface area and volume? You have been studying this topic from grade 5 or 6 under the topic mensuration, correct? So let us see what all new we are going to study today, okay? So in our day-to-day life, we come across so many things, of which few are solids, correct? You check your phone, that's in the shape of cuboid, right? You play with Rubik's cube, it's nothing but cube. You eat a cone ice cream, it's nothing but in the form of cone. Next, we also see objects which are combination of two or more solid figures. So here you see a test tube, correct? So you use test tube for experiments in your laboratory, science laboratories. So how is this a combination of two solids? So when you observe it carefully, it is a cylinder till here and this part is hemisphere, correct? So the top part is nothing but cylinder. So I'll write this as cylinder and the bottom part is hemisphere, correct? All right. So this is one of the examples where we see combination of two solid figures, that is cylinder and hemisphere, right? So now can you all give an example in where you see a combination of two or more solids? Please do answer in the comments. All right, I'll be checking it. Next. So now we are done with studying or just brief explanation of what is combination of solids. So to understand better, we need to know the formulae of all the solid figures which we are going to discuss today, correct? So let us revise one by one. So first is cuboid. What's cuboid? Here you see this figure, correct? Okay, movie promos, please repeat. Okay, so this is just the introduction. We have just begun the class today now, okay? So in our day-to-day life, we come across so many things, correct? And of all those, there are few solids like cuboid. a notebook is in the shape of cuboid, your phone which you're holding, or desktop or laptop which you're looking is almost in the shape of cuboid, correct? And Rubik's cube is in the shape of a cube. Your ice cream, when you hold a cone ice cream, it is in the shape of a cone, correct? So these are few solids we see day to day, or we come across day to day in our day-to-day life. But sometimes we also see objects which are combination of two or more solid figures. So what is meant by it? So now in the figure, here is a test tube which you use in your science laboratory, correct? So when you observe it carefully, you will notice that this test tube is a combination of two solids. What? The top part from here till here is a cylinder, and the bottom part is nothing but hemisphere. So this test tube is the combination of cylinder plus hemisphere. Okay. So now I have asked a small question, that is, can you all name one more solid figure which you observe in your day-to-day life and it is the combination of two or more solids? I'll tell you one, ice cream. So if I just draw an ice cream, this is again the combination of cone plus hemisphere, correct? So we can actually give many examples of this kind where one object is the combination of two or more solids. So by the time I discuss the next, you can comment what all solid objects you observe which are the combination, okay? Moving to the next. So movie promos, did you understand now? You asked me to repeat. So I hope it's fine now. And also please tell your name so that I can call by your name. Okay. Next. So to apply these concepts, what is the basic thing we need? We need to know the formulae of surface area and volume of few solid figures. So here we will be recalling all the formulae or all the required formulae of the solid figures. So the first one here is cuboid. What do we know about cuboid? Cuboid is a 3D figure, or cuboid is a solid figure which has 3 dimensions: length, breadth and height. You can also tell length, width and height, correct? So here L is the length of the cuboid, B is the breadth of the cuboid and H is the height of the cuboid. And what will be the total surface area of cuboid? 2 of LB plus BH plus LH. Okay, hi Sagar Kumar, good to know you're in class 10, alright. So I hope you're following all the sessions and it's helpful to you, and you are already aware, right, that the timetable is released. So how's your preparation going on? Hope it's going well. Alright, now let's go back. Lateral surface area of cuboid. What is lateral? Means you just remove the top and bottom, the side portion. So lateral surface area of cuboid is 2HL plus B, where H is height and LB are length and breadth of the cuboid respectively. Next, volume of the cuboid. What is volume of the cuboid? Length into breadth into height. Hi Lakshmana Prabhu, how are you? Okay. All right. Next is cube. What is cube again? You know, right? This is the cube here where all of its edges are of equal length. So let us consider the edge of the cube to be of length A. So this is A, correct? So if the length of the edge of the cube is A, what will be its total surface area? Total surface area of cube is equals to 6A square. LSA, that is lateral surface area, is 4A square, and volume of the cube is A cube. Alright. Next we are discussing about cylinder. So here is the cylinder, and let me mention the height and radius of the cylinder. So this is the radius and this is the height, correct? Now we know what is radius and height. Let us see the formulae. What is TSA of cylinder? 2 pi r of r plus h, where r is radius and h is height. And what is curved surface area of cylinder? It is 2 pi r h, and volume of the cylinder is pi r square h. And in all these, r is nothing but a radius, h is nothing but height. Okay. Next, I am fine too, Lakshmana Prabhu, thank you. Next is cone. To study cone, we need one more parameter, that is slant height, which is represented by the letter L. Now this will be the slant height of the cone. Okay, you can represent it by L, and as we all know, this will be the radius and this will be the height. Okay, yes, I am telling about slant height. Just a minute. Okay, so slant height is nothing but this measurement of the cone. So how do you find the slant height? We can use the Pythagoras theorem to obtain the slant height. So if this is L, this is also L, correct? And this height is nothing but perpendicular distance to the base. So this will be 90 degrees. And when you apply the Pythagoras theorem, that is hypotenuse square is equals to side square plus side square, we will be getting L square is equals to R square plus H square. We will also be using this formula wherever required. Okay. Now, total surface area of cone is equals to pi r of r plus L. Again here r is radius and L is the slant height of the cone. Okay. Next, lateral surface area of the cone, or you can also name as curved surface area, it is pi r L. Next, volume of the cone is 1 by 3 pi r square h, and slant height of the cone we have already discussed here. But what if you want only the value of L? You can write L is equals to under root of r square plus h square. Correct? So this is about cone. You have also learned what is the slant height of the cone. Right? Moving on to the next. Sphere. So sphere is nothing but imagine a ball, right? So what is total surface area of sphere? 4 pi r square. So whenever you are asked curved surface area or total surface area of sphere, it means the same. Okay. Next, volume of the sphere is equals to 4 by 3 pi r cube. Next, hemisphere. Okay, there is no figure for it. Let me first draw it. So this is a hemisphere, correct? And this is the radius. This is also the radius, right? So here is the hemisphere, and then we will see what is TSA, CSA and volume of hemisphere. Total surface area of hemisphere is equal to 3 pi r square. So what is meant by total here? If the hemisphere is like this. So this area plus the bottom circle. So when you add these two, you will be getting the total surface area of hemisphere. Curved surface area of hemisphere is 2 pi r square. Next, volume of the hemisphere is 2 by 3 pi r cube. Alright. So we have almost seen all the formulae which are required. So yes, you can take the screenshot if you want, because you will be finding all the formulae at one place. So cuboid, cube, next cylinder, cone, sphere and hemisphere. Okay. So next, we are done with discussing formulae. What is next topic? Next, we will be seeing surface area of combination of solids. So just in the first slide, as we have discussed, there are many objects here in day-to-day life we see where one object is combination of two or more solids, correct? We have seen the example of test tube, we have seen example of ice cream, and even if you just take a home, okay? Let us just take a home like this, and this is also the volume of this plus volume of this, correct? Or if you want to find the surface area of this plus surface area of this. So that is what we will be discussing now, and also solve some examples and problems on it. So here you see a toy, right? Can you all tell me what shape it is? Does it have any shape which can be called in particular? No, right? It is the combination of cone and hemisphere. This is hemisphere and this is cone. So now I want to find the total surface area of the toy. How do I find? I can easily tell that the CSA of cone plus CSA of hemisphere is nothing but the total surface area of the toy. So surface area of the toy is equals to CSA. Again, CSA is nothing but curved surface area, okay? So I'm just mentioning here because instead of writing it completely, I'll be mentioning CSA, LSA and TSA, okay? I hope it's fine. CSA is curved surface area, LSA is lateral surface area, TSA is total surface area, okay? Right. So CSA of cone plus CSA of hemisphere, right? So if I calculate CSA of cone here plus CSA of hemisphere, I will be getting the total surface area of the toy. Alright, so this is one of the examples we've considered. Now let us apply this and solve few problems, okay? So here is the first problem. The decorative block shown in the figure is made of two solids, a cube and a hemisphere. The base of the block is the cube, alright, so here is the figure. So the base is nothing but cube of edge or edge length 5 centimeters. And the hemisphere fixed on the top has diameter of 4.2 centimeter. So while solving your surface area and volume questions, make sure what parameter is given to you. Is it diameter or is it radius? Okay. Next, find the total surface area of the block. Alright. So first, here's the figure. Now let us decode how to find the total surface area of the block. Okay. TSA of block is equals to, what is it? First, let me just write the complete TSA of cube minus the circular portion, because it is covered, correct? We need not find that. So, TSA of cube minus area of circle. Why? Because this portion of circle is closed and we do not want that to be considered to find the total surface area of the block. So minus area of circle plus what is it? This is hemisphere. So CSA of hemisphere plus CSA of hemisphere. So now that we have decoded, we'll just substitute the values in the formula and then we can find it, right? So what is TSA of cube? 6a square. So I'm just writing area is equal to 6a square minus area of the circle. But to find area of the circle, okay, we need to know what is the radius. The diameter is given 4.2 centimeters. Can you tell me what will be the radius? Hi Umesh, how are you? You're my old student. Okay, good. Thank you for watching. And I hope you learned much more in today's session. So yes, if diameter is 4.2 centimeters, what will be the radius? Please do type in the comments. It's very easy, right? You know diameter, it's very easy to find radius. Okay. Alright, so we know that radius is equals to diameter by 2, correct? So diameter is equals to 4.2 centimeters, radius is equals to 4.2 by 2, that is nothing but 2.1 centimeters, right? Now, so what is area of circle? Minus pi r square. Next, plus CSA of hemisphere. What did we learn about the formula of CSA of hemisphere? It is 2 pi r square. So this will be plus 2 pi r square, right? This is what area of the block. Correct? Now let us substitute. What is the length of the edge? 5. So 6 of 5 square minus pi r square plus 2 pi r square is plus pi r square. So plus 22 by 7 into r square. What is radius? 2.1. Just substitute it. So 2.1 into 2.1. Right? So let us find out. 5 square is 25. 25 into 6 is what? 150. Correct? 65. Yes. 150 plus 7 into 0.3. So let us calculate this. 21 into 3 is how much? 2 into 3 ones are 3. 3 twos are 6. 63 by 100. That is 0.63. So what is 22 into 63? Let us do it. 3 twos are 6. 3 twos are 6. 6 twos are 12. 6 12, 13. 6, 6 plus 2, 8. 1386. So 150 plus 113.86. So what we'll get? 163.86 centimeter square. So just be sure with your calculations when you calculate, okay? So now what is the area of the block? You can just write concluding statement when you are giving your exam, because this time it is subjective paper, correct? So whenever it is subjective paper, your each step will be considered and there is a marking scheme for each step. So make sure you write it in steps and just write the concluding statement. Thus area of the block is 163.86 square centimeters or centimeter square. I'm sorry. Also be sure of the units you mentioned. Okay. Let us go with next question. From a solid cylinder whose height is 22.4 centimeter and diameter 1.4 centimeter. Okay. First let us draw a solid cylinder. So let me draw a cylinder. Okay. The height is 2.4 centimeters. All right. This is 2.4 centimeters. Next. And diameter is 1.4. See, again it is diameter given. If diameter is 1.4 centimeter, what will be the radius? Radius is equals to 1.4 by 2. That is 0.7 centimeters. Correct? So just mention the radius here or here. That is 0.7 centimeter. Next. A conical cavity of the same height and same diameter is hollowed out. What is meant by hollowed out? They have cut the cone shape and they have removed it from the cylinder. Okay. Now let us use another color to represent cone. So this is a cone. Correct? Now this is hollowed out. In it also has same height and same radius. Next, find the total surface area of the remaining solid to the nearest square centimeter. Okay, so what do we have to find? We have to find the total surface area of the remaining solid. So just imagine, okay, take a cylinder, just remove a cone part. Now what will you find? There's a cone inside and outside is a cylinder, correct? So now we'll do it. TSA or total surface area of remaining solid. What is it? Curved surface area plus of cylinder. So CSA of cylinder, alright, plus the area of the base. What is the base? Circle. So I'll just write area of base and we know that it is a circle, right? And curved surface area of cone. So plus CSA of cone. Now we know all the formulae of this. We know what is CSA of cylinder, area of base and also CSA of cone. Let us just write the formula and substitute its values. So it will be TSA of solid is equals to, what is CSA of cylinder? 2 pi r h. 2 pi r h plus area of the base circle, that is pi r square. Pi r square. Next, CSA of cone. What is CSA of cone again here? Pi r l. And do we have the value of slant height? No. So we also have to find that. So let me find here. L is equals to under root of r square plus h square. So what is the radius? 0.7 centimeters. What is the height? 2.4 centimeters. So just substitute 0.7 whole square plus 2.4 whole square. So what we'll get? 0.7 whole square is 0.49. This is 5.76. So this will be 9 plus 6, 15, 7 plus 4, 11, 12, 12.6.25. So this is 2.5. So the slant height is 2.5. So now we know all the values, we'll just substitute it. So can I take pi common? I can also take r common. So let me take pi r common. 2H plus R plus L. So let us substitute 22 by 7. What is the radius? 0.7. So 7 by 10 into, what is height? 2.4. 2 into 2.4 is 4.8. What is R again? 0.7. And L is 2.5. Right? So we have substituted the values. Let us find it. 22 by 10 of. So 4.8 plus 0.7 plus 2.5. 8 plus 7 is 15 plus 15, 20. 4 plus 2, 6 plus 2, 8. 8. So 8 2s are 16, 8 2s are 16, 17. 176 by 10. So it is 17.6 centimeter square. So if you are presenting in the exam again, just write a concluding statement, that is, thus the area of the remaining solid is equals to 17.6 centimeter square. Alright, next. Volume of combination of solids. So we have just covered what is surface area of combination of solids. Now let us see what is volume of combination of solids. So here we have an example. Let us look at that. A juice seller was serving his customers using glasses as shown in the figure. So this is a glass, correct? And this is a cylinder and this is a hemisphere, correct? It is closed. Now, volume of the glass is equals to volume of cylinder minus volume of hemisphere, correct? So here, this is the combination of solid, cylinder and hemisphere. So to calculate the volume of the glass, how do we calculate volume of the cylinder minus volume of the hemisphere? Okay. So let us apply the same logic and same concept to solve further problems. So here's the first one. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Okay. So a solid is in the shape of a cone standing on hemisphere. So let us draw the figure first. So there is a hemisphere. On it, there is a cone standing, okay, and both of their radii is 1 centimeter. So this is 1 centimeter, and the height of the cone is equal to its radius. So R is equals to H is equals to 1 centimeter, correct? Next, find the volume of the solid in terms of pi. So no need to substitute the pi value, we can just find it out. So volume of solid is equals to volume of cone plus volume of hemisphere, right? So let us substitute the values. What is volume of cone? 1 by 3 pi r square h. What is volume of hemisphere? 2 by 3 pi r cube. So substitute r is equals to h is equals to 1. So 1 square into 1, 1. So 1 into pi by 3. Pi by 3 plus, again r cube, 1 cube, 1. So 2 pi by 3. That is nothing but 3 pi by 3. 3 cancel. So it is pi centimeter cube. Since they have asked only in the terms of pi, no need to substitute the value of pi. Next. A spherical glass vessel has a cylindrical neck 8 centimeters long, 2 centimeter in diameter. Okay, there is a circular glass like this and there is a cylinder here. Okay. And the diameter of the spherical part is 9 centimeters. So if diameter of like spherical part, so let's S, is equals to 9 centimeters, what will be its radius? Radius will be equals to 9 by 2. So R is equals to 9 by 2 is equals to 4.5 centimeter, right? So this radius is 4.5 centimeter. Next, cylindrical neck is 8 centimeters long. That is, this is 8 centimeters. And what is the diameter? It's 2 centimeter. So if diameter is 2 centimeter, radius is 1 centimeter, right? So now we have all the values which we have decoded. So let us just find the volume. So volume of container. What is the volume of the container? Volume of the sphere plus volume of the cylinder. So just write volume of cylinder plus volume of sphere. Now substitute the values. What is volume of cylinder? 1 by 3. Sorry, not 1 by 3. Okay. What is the volume of cylinder? Pi r square h. And what is the volume of a sphere? 4 by 3 pi r cube. 4 by 3 pi r cube. Now let us substitute the values. So volume of container is equals to pi r square h. R is, what is this? Volume of cylinder. So let us mention this R1. This is R2. Okay, what is R1? 1 centimeter. And what is the height? 8. So pi into 1 square into 8 plus 4 by 3 pi into 4.5 centimeter is the radius. So 4 by 3 pi 9 by 2 whole cube. So you can also write 4.5, no issues. But just for easier calculation, I have mentioned 9 by 2, right? So this is 8 pi plus 4 by 3 into pi into 9 by 2 into 9 by 2 into 9 by 2. So 3 times 1, 3 times 3, 2 2s are 4, this 4. So what do we get? 8 pi plus 9 9s are 81, 81 into 3. What is 81 into 3? 3 8s are 24, 243. 243 by 2. So 2 1s are 2, 2 2s are 4, 2 1s are 2 again, 121.5. 121.5 pi. So it is 129.5 pi. So what is the value of pi? They have asked us to take 3.14. So just multiply this 129.5 into 3.14. You will be getting the answer in centimeter cube. Correct? So I'm not doing the calculation. I hope you can do it. It's very easy. Correct? Next. Conversion of solid of one shape to another. So we have seen volume of combined solid or combination of solids and surface area of combination of solids. Now let us see how to do or how to find when one solid is converted to another shape. Okay. So here one spherical wax ball is melted and turned into 3 cylindrical candles, right? So here we have one spherical wax ball. This is melted, okay? And it is converted into 3 cylindrical candles. So now what do we have to find or what do we know about this? When one object is melted and recasted into the another solid, the volume remains same, correct? We are not so sure about surface area. It may or may not be same, but we know for a fact that volume is same, right? So here volume of this sphere is equals to sum of volumes of or sum of volume of 3 cylinders, correct? So what did we learn from this? We have seen that when one solid object is converted into the other solid objects or one or more objects, we see that volume remains same. So in the question, if it is asked that one solid is converted to the other, you can take volume and find out, right? So we have seen the concept. Now let us understand and solve 2 questions on this, okay? So since it is surface area and volume, it's most on how you solve the questions or how many questions you solve, correct? So that is the reason I have picked 2 questions from each topic and I'm solving, okay? So that it will be revised for you as well. A well of diameter 3 meter is dug 14 meters deep. what is well? It's in the form of cylinder, correct? So first let us draw it. Okay, this is a well. So diameter is 3 meters. So if diameter of well is 3 meters, what will be its radius? 3 by 2, that is 1.5, correct? So radius of well is equals to 1.5 meters. Next, the height or depth. So when it is dug, we calculate it as depth, correct? So what is the depth of the well? It is 14 meters. So depth, or when you substitute in the formula of volume of cylinder, you take h, correct? This is 14 meters. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meters. So what is meant by this statement? The soil, which is, you dug the well, you get the soil, correct? That is taken out and framed in the form of a circular ring, and the width of the circular ring is what? 4 meters. So around it, it is given. So let us just draw like this, correct? Around it. So this width is 4 meters. Next, to form an embankment, find the height of the embankment. All right. So we have to find the embankment. So this again will be form of a cylinder, correct? So we know the width, but there is outer radius and inner radius, right? So let us take RB, inner radius of embankment, which is nothing but the radius of the cylindrical well, that is 1.5 meters. So it is 1.5 meters. And let capital R be its outer radius. Right? So what will be the outer radius? Inner radius plus width of the circular ring, correct? So R is equals to 1.5 meters plus 4 meters. 1.5 plus 4 is equals to 5.5 meters. So see, this will also be like in a cylindrical shape, okay? It will be like this. Right? So this is 1.5 and this width is 4 meters. So what will be the complete radius or the outer radius? It will be 1.5 plus 4, that is 5.5, correct? So that is what we have got here. Now what do we have to find? We have to find this height of the embankment, right? So let us do it. Let us just write in a formula. We know the formulas, just substitute the values given, right? So volume of earth taken out, volume of earth taken out is equals to volume of the embankment. So volume of embankment, right? So what is the volume of the earth taken out? Cylinder. What is the volume of the cylinder? Pi r square h. So write pi r square h. Rw is radius of the well or cylinder. And what is volume of the embankment? Pi of capital R square h minus pi of small r square h. Why? Because that is embankment, correct? It is just in the form of a ring. So what do we do it? Volume of the outer, cylinder minus volume of the inner cylinder, we will be getting the ring volume, correct? So that is what we have done here. So I can write it as pi h of capital R square minus small r square. This is pi h of Rw whole square. Pi h, right? That is why do not substitute the value of pi immediately after, substituting. Just check whether it can be cancelled. If it can be cancelled, why to substitute and making it complex, correct? You can just cancel it in the form like this. Now, what is radius of the well? 1.5 meters. So, 1.5 into 1.5 is equals to, what is capital R? It is 5.5. What is small r? It is 1.5. So, 5.5 whole square minus 1.5 whole square. Now again, let me tell you a trick. Please do not calculate 5.5 whole square and 1.5 whole square and subtract it. You can use an algebraic identity for this, correct? Why? It is in the form of a square minus b square. And what do we know about this identity? A square minus b square is equals to a plus b into a minus b, right? So let us use this now, okay? So let me write 1.5 into 1.5. Alright, so this is where we made a mistake. This height and this height is different, correct? This is h. So what is this height now? What is the height? 14 meters. So it is 14. Okay, so this is h. H is what we have to find. Now 5.5 plus 1.5 is how much? 7, correct? So 7. What is a minus b? 5.5 minus 1.5? 4 into capital H. Now we have to find this height. So H is equals to 14 into 1.5 into 1.5 by 7 into 4. Isn't the calculation simple when you use the identity? Because when you multiply, you make it so complex, you also waste your time. So we have to save time. So this is the method we follow. Whenever you see a square minus b square, just apply the identity, okay? Until unless it is easy to solve this like this. Next, 7 times 2, 2 times 2. 1.5 into 1.5 is how much? 15 into 15 is 225. 2 decimal points. So 2.25 by 2. So 2 ones are 2, 2 ones are 2, 2 twos are 4, 1.125. So the height of the embankment is 1.125 meters. Is it in meters or centimeters? It's in meters. So of course, height of the embankment is 1.125 meters. Okay, so this is about the problem and it's very simple. You have to just understand it and apply it. Okay, because you know the formula by now, correct? Next, metallic spheres of radii 6 cm, 8 cm and 10 cm respectively are melted to form a single solid sphere. So again, this is the concept of what? Conversion of one metallic solid into another, but it's of a same shape. That is, these are also spheres and the resulting shape is also sphere. Correct? So if you know the formula for volume of sphere, you can easily do it. So yes, metallic spheres of radii 6, 8 and 10 centimeters respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. Alright, let us do it. So R1 is equals to 6 centimeters, R2 is equals to 8 centimeters, R3 equals to 10 centimeters, right? And we have to find the capital R. So what is the capital R? It is the radius of the resulting sphere. Or you can just write, let capital R be the radius of resulting sphere. Correct? Now just substitute the formula. So, sorry, 1 second. Yes. Volume of resulting sphere. Okay. Resulting sphere is equals to sum of volumes of all these three spheres. So you can write volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3, right? Now just apply the formula. What is the volume of sphere? It is 4 by 3 pi r cube. And here we have taken it to be capital R, right? So just write here 4 by 3 pi capital R whole cube. And here 4 by 3 pi R1 cube plus 4 by 3 pi R2 cube plus 4 by 3 pi R3 cube, right? Now, can we take 4 by 3 common in all this in the equation? Of course, we can take. So, let us take 4 by 3 pi of capital R whole cube is equals to 4 by 3 pi R1 cube, okay, this is R, plus R2 cube plus R3 cube. Correct? Very simple, nothing complex. 4 by 3 pi, 4 by 3 pi is cancelled. Now you can easily find R cube is equals to, now substitute the values. What is R1? 6, R2 8 and R3 10. Again check if it is given radii. It is given radii. If it is given diameter, to find the radius and then substitute. Okay? So this will be 6 cube plus 8 cube plus 10 cube. So what is 6 cube? 6 square is 36, correct? So 36 into 6, 216. So 216. What is 8 cube? 8 square is 64. So let us find 64 into 8. 8 times 4 is 32. 48 plus 3, 51. 512. So 512. 10 cube is easy, right? Right. Okay. Now just find the sum. So 1 here it will be plus 6, 8. 1 plus 1, 2. Plus 1, 7, 2, 8. Right? So we have to find whether 1728 is a perfect cube or not. How do we find? We can just use prime factorization, correct? So fine, let us also do that. 1728. So is it over 6? I'll directly go with 6 because you know why taking more steps in doing. If I know that is a perfect cube, 6 times 2 is 12, 52. 48, yes. So 6 2s are 12, 5 2 6 8s are 48, 4 8 6 8s are 48. Again 6 4s are 24, 6 8s are 48, 6 8s are 48, 2 into 2, 2 into, sorry, this is 4 into 2, 2 into 1. So 6 into 6 into 6 into 2 into 2 into 2, right? So it is 6 cube into 2 cube. 6 into 2 whole cube, 12 cube. So when R cube is equals to 12 cube, R is equals to 12. So what is 12? Is it centimeters or meters? It is centimeters. So let me write centimeters here. Okay. So again you can write a statement at the end. Thus the radius of the resulting sphere is 12 centimeters. Right? So yes, this is about this problem. We have solved it. So just make sure when you are doing the surface area and volumes, read the question twice, understand what parameters are given, okay, and also check the units, because sometimes it will be meters height and radius centimeters. So make sure you convert them into one unit. You can either do it in meters or centimeters, but make sure you check the units carefully, okay. So, and what else about surface area and volumes? Just write stepwise. Remember the formulae, every formula, and make sure if you're finding TSA or LSA or CSA, correct? So these are some important points while you're solving the surface area and volume questions you have to remember. So I've taken almost 2 problems for every concept, and the frustum topic is deleted, correct? So if you are from CBSE and if you are praying for term 2, there is no need to study frustum and no need to study formulae also, because that topic is deleted, and these are the topics we have, right? I hope it is clear, and let us once go through the schedule and end the session, okay? So today we have studied surface area and volumes, and on 14th February, that is on Monday, you have the session on our environment, okay? Next on 15th, that is on Tuesday, you have statistics. On 16th, you have magnetic effects of electric current. And next coding you have class today. Do you have class today? Yes, 8 to 9:30 you have class. Please do attend it. Next we have 16th and 28th February. Okay. Okay, I'm done with today's session. I hope it's clear, and I hope you all have followed the session and understood each and every problem. All right. Okay. All right. Thank you, everyone. Bye.